Today we're looking at Learning Target 7b, which is being able to graph a square root function and identify the key features. Before we talk about graphing, let's identify what a square root is. A square root is a number a such that y squared is equal to a. Some examples are shown below. Notice the way that we can figure out what the square root of a number is. Let's take, for instance, the square root of 16. What number times itself equals that number inside the square root? In this case, we know that 4 times 4 equals 16. Therefore, the square root of 16 is equal to 4. Here's the list of the first 10 square roots and their answers. We also must be able to identify key features of a graph. There are 3 things that we're going to need to be able to identify by the end of this learning target. The first thing is the vertex. The vertex is that starting point of the square root graph. Domain and range are 2 vocab words we've looked at before. Domain, remember, is all the x values covered by a graph, and the range is all the y values covered by a graph. The standard equation for graphing square roots is y is equal to a times the square root of x minus h plus k. Notice that x minus h is inside the square root and that k value is outside the square root. When you look at this, whatever number takes the place of h is the x value of your vertex, and whatever number takes the place of k is the y value of your vertex. So if you look here, we've got that the h here is your x value, and the k here is your y value. The a represents your vertical stretch, and we'll look at that and how that affects the graph here shortly. So let's go ahead and start looking at graphing square roots. To help us with this, we're going to actually be using our graphing calculator. So if we look at the first function, y is equal to the square root of x, I'll go ahead and pull up my calculator. Start by turning it on. And I'm going to go to the y equals. Here I'm just going to punch in the square root of x. The square root button is located 4 down from that blue second button. Now notice it is in blue, so we have to hit that second button before we hit that square root button. So I'm going to go ahead and hit the second button. Notice my calculator can tell that I hit the second because it gives me that up arrow. And I'm going to hit that x squared button, which doubles as the square root. And then I'm going to hit x right next to our alpha button. And close my parentheses. I like to start by looking at the graph. That way I get an idea as to what my graph is going to kind of look like. Now, in order to graph this, I'm going to actually look at my table. Now notice with this table, we get a lot of decimal answers. For the sake of graphing, I'm only going to graph the whole number pairs. So for instance, 0, 0 is located right here on the graph. 1, 1, go to the right one, up 1, and it's located there. I'm going to skip 2 and 3 for the x values and go to 4 because it has a whole number value for y. So I'm going to go over to 4 and up 2 and plot that next point. I'll go ahead and scroll down until I find my next whole number pair, which is at 9, 3. And plot that point. At this point, my next whole number pair will not come until 16. So that's all I can fit on this graph. So now I can sketch this graph, and notice it will continue on forever in one direction. In this case, my vertex, or my starting point, is at 0, 0. So I can label that as my vertex. My domain. remember, is all the x values covered by a graph. So in this case, the graph starts here at 0 and will continue forever in the direction greater than 0. So the way I'm going to write my domain is that its x must be greater than or equal to 0. My range value is my y's. So notice in the blue here, my graph again starts at 0 on the y's. And if this were to continue going, it would continue growing and growing slowly, but eventually would cover all of my y values. So the way that I write my range is that y is greater than or equal to 0 as well. Let's go ahead and look at another function and graph that and identify the key features. In this case, we're looking at y is equal to the square root of x minus 5 plus 2. Again, notice that that x minus 5 is inside the square root and that plus 2 is on the outside. So I'm going to go back to my calculator, go to my y equals, clear out that equation, and I'm going to go ahead and type in the next equation. So hit second and bring up the square root, type in x minus 5, close my parentheses. When I close my parentheses, that ends the square root piece, and then plus 2. Go ahead and hit the graph button just so I get an idea as to what it will look like. And then I'm going to look at my table. Now, when I look here, before I go to my table, I can see it's going to start somewhere right around 5 and up a little bit. So when I look at my table, I'm going to start by trying to find that 5. And notice here in the table I've got these error messages. That tells me that my graph is not there. So notice here that my graph starts at the point 5, 2. So I'm going to plot that point 5, 2 on my graph. My next whole number pair is 6, 3. So I'll plot that point. And I'll go down to the next whole number pair, which is 9, 4. And I'll scroll down just to make sure. My next one will be at 14, 5. So again, that's off the graph. But I've got an idea as to what my graph is going to look like. So I can go ahead and sketch my graph. Now, you may recall from the pages earlier that my vertex can be found by looking at the first equation. So by understanding the way the format works, I should be able to see that my vertex would have been at 5, 2, which we found also by using the table. So I can label my vertex at 5, 2. My domain, again, is all the x values covered by the graph, starts where x is 5, and continues forever in the greater than area. So I can say that my domain is that x is greater than or equal to 5. My range, again, is all the numbers on the y value. So looking at my graph or looking at my vertex, I know it's going to start at 2, and if it were to continue going, it would eventually cover all the y values greater than 2. So my range is that y is greater than or equal to 2. Let's go ahead and look at one more example. And again, I'm going to use my calculator to help me out. So I'll go to my y equals, clear out this function, and I'm going to type in this new function. So we've got 2 times the square root of x minus 5 plus 2. Again, I'm going to go ahead and look at my graph. Even though I know where my vertex is going to be, it will be at 5, 2. I'm still going to look at my graph just to make sure. Now notice here, it's climbing a lot quicker. And I can tell that because of this A value, the vertical stretch. Tells me that it's going to be actually double what the normal square root would look like. Now, instead of trying to graph it by hand, I'm again going to use the table to help me out. I know that vertex is going to be at 5, 2, so I'm going to go find that and confirm that using my table. So I'll plot that point at 5, 2. Again, I'm just graphing whole number pairs, so I'll go to 6, 4 as my next one, and 9, 6 for my third one. I'll again scroll down just to make sure that my next whole number pair is off my graph, which indeed it is. So I'll go ahead and graph this function. Now I can go ahead and list my vertex, which I already know is at 5, 2, based on looking at the equation, and also confirming it on the table. My domain, again, starts at where x is 5 and will continue forever in the greater than direction. So we got x is greater than or equal to 5. And my range goes from where y is 2, and again, if I continue it, it will eventually cover all y values. This time it climbs a little quicker because of that vertical stretch. But either way, it will end up covering all those graphs, or all those numbers greater than y. Here are a couple ones for you to practice with. Feel free to use your graphing calculator to help you in plotting these and finding those key pieces of data. If you have any questions, please make sure you ask Mr. Dunn, Ms. Knutson, or myself.